All right, in this section, we're going to look at triangles. Now, again, this is just very basic information. We're going to go into a lot more depth into triangles as we go throughout the year. In fact, we'll probably spend about 6 to 8 weeks on triangles because they're just very important figures in both geometry, nature, architecture, and there's a lot to it. We'll look at trigonometry. We'll even go into some pre-cal with the triangles because it fits so well with what we're going to be doing. All right, now in this video, there are going to be a couple of vocabulary terms in here. I'm going to have you practice writing good geometric definitions. When you get to those, pause the video, write a definition for it, then we'll just make sure that our two definitions are the same. All right, for a right triangle, pause it real quick, write a definition on what you feel a right triangle is, unpause it, and then see if we have the same thing. Okay, a right triangle is a triangle with exactly one right angle. Can only have one. Okay, the other two can be whatever, any other acute angle, as long as it has exactly one right angle. For an acute triangle, pause the video now, come up with a definition, and then unpause it to see if we get the same thing. And an acute triangle is a triangle with all acute angles. Pretty simple. All the angles have to be acute. Finally, an obtuse triangle. With an obtuse triangle, again, pause the video, write your definition, and unpause it. An obtuse triangle is a triangle with exactly one obtuse angle. Can only have one. Can't have more than one. One and only one. Next, a scalene triangle. Again, you should have talked about all these in middle school, but go ahead and pause it real quick and write your definition. Okay, a scalene triangle is a triangle with no congruent sides. No congruent sides. Have to all be different. An equilateral triangle. You can pause the video, unpause it after you have your definition. It's a triangle. Oops, forgot a space. With all congruent sides. All of them have to be the same. Now remember, in a triangle, all the angles also have to be congruent. This is the only polygon that's the case. Another way to think of an equilateral triangle is that it's a regular triangle, because all the sides and all the angles are congruent, so that makes it regular. Finally, an isosceles triangle. Write your definition of this one, then unpause the video. Okay, so an isosceles triangle, it's a triangle. Now, you might not have this in your definition. If you don't, make sure you add it. It's a triangle with at least. That's a big key phrase there, at least two congruent sides. So an equilateral triangle is actually an isosceles triangle. But an isosceles triangle is not necessarily equilateral. Okay, so it has to have at least two. All right, now the parts of an isosceles triangle. So let's say in our isosceles triangle, we only have two sides, kind of the more traditional definition, or the way that you would think of an isosceles triangle. We've got two congruent sides. The side that is not congruent is called our base. Okay, that's our base. And in geometry, the base does not have to be on the bottom. It can be anywhere. And I'll show you here after I get done label everything. I can turn this triangle around, and the base would still be the non-congruent side. The two sides that are congruent, they're just called sides. Nothing real complicated there. They're just sides. Just put it right there. Excuse me. Okay, so those are sides. The angles that are formed with a side and the base are called base angles. And those two angles are congruent. And finally, your third angle, the angle that's not congruent, would be this one here that's formed by the two sides, and that is called your vertex angle. Now, this tends to be very confusing in geometry, so I do want to show this here. Let me group these together. All right, so if if I rotate this, I don't care how I turn it, the base will always be the base no matter how it's turned. Even though this is on its at an angle here, it's pointing up, it's still the base because it's the side that's not congruent to the other two in an isosceles triangle. Okay, so it doesn't matter how it's drawn, the base is different in math. It doesn't have to mean the bottom. All right, what I'd like for you to do is construct a triangle using a compass and straight edge only. It has to be equilateral. You cannot use the ruler part of your straight edge, and you cannot use a protractor. So only make this triangle using those two construction tools. And be prepared to talk about this in class tomorrow. And finally, the last example I'd like for you to look at. I want you to find a point C, and again, I want you to do this on your own, or you could, text somebody, call somebody, whatever, or if you're watching it with a friend, work on it with them. But I want you to think of where a point could go for point C that it would form a triangle that is isosceles. There are a lot, in fact, an infinite number of answers. I want you to be able to figure out what those answers are and what points it could not be. Okay, so start thinking about those things, and we'll discuss those in class tomorrow. And that's it for this video.